Today we are going to be looking at addition and subtraction of equations, and we're going to use what we already know about numerical and algebraic expressions to help us learn about algebraic equations. If you remember, when we were working with numerical expressions and algebraic expressions, we did not use the equal sign. Well, now we're going to be looking at equations, and the equations do have equal sign. So for example, if we're looking at 7 plus 2 equals 9, this is an equation. 7 plus 2 equals 9 is an equation. We're going to look at both sides of the equal sign. So 7 plus 2 equals 9. And this equation is true because 9 is equal to 9. Let's look at 10 minus 2 equals 8. This is an equation. 10 minus 2 is 8, and this equation is true because 8 is equivalent or equal to 8. Now let's apply that if we were looking at a balance and we were looking at an algebraic equation. So let's look at this part. On this balance, you can see the equation f plus 6 equals 10. If I'm looking here, I can see that the triangle here represents the variable f. And then I can see 6 ones, so f plus 6 over here on this side of my balance is equivalent or equal to the 6. It's equal or equivalent to this side. So we see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ones over here, and these are equivalent. Now, if I am looking for f, I can solve for f. But we're not solving for this equation. If I wanted to, however, I could solve for f. But for right now, we're not going to solve for f. We're going to leave f as it is, as in a variable. But this just shows how we can make both sides of the equal sign equivalent. F plus 6 equals 10. Let's look at our next example. We're going to model and write an addition equation, okay, on this one. And down here, we're going to model and write a different equation. So let's start with the addition equation first. When we are looking at this, Jane has some money M. She finds $6. She now has 22. The first part of this equation is similar to what we've already been doing when we're looking at expressions. So some money M, we would represent the variable M. She finds $6, and we know the word finds is going to tell us to add $6. And now we're going to add our equal signs. Now she has 22. So M plus 6 equals 22. And that is what this equation is saying. Now we have to model this. So we're going to use what we know about models to model this equation. So M plus 6. We would do this exactly like we have done the rest of our addition models. So over on the first box, we would put the M. Second box, we would put the 6. Now what's different is this part, equals 22. And the way that we do that is that we add another box, and we put 22 inside of it because this represents the M plus the 6. That gives us a total of 22. So this is how we would model this equation. Let's look at our next example. There are 10 dog toys in a basket. After the dogs pull some toys out, there are 3 toys left. So we're going to pay attention to this part, that there are 10 dog toys in a basket. So we know that 10 are there. After the dogs pull some out, so they pull some toys out, so we're going to subtract T. There are 3 toys left, equals 3. 10 minus T equals 3, because there are 3 toys left. Now, notice that there is no variable given within this word problem. However, at this one, m was given. We knew to use the variable m. Here in this word problem, no variable was given, so I had to come up with my own variable. And since we were talking about dog toys, I chose to use the variable t to represent the toys. Now, when I'm looking at making a model, remember I can use what I already know about models to help me with equations. So 10 minus t equals 3. We're going to do this a little differently. The 10 is represented first. 10. What's been taken away from the 10 is 3. We usually would put that dotted box over here. Remember when we would do that? Now, since we're doing an equation, we're going to move that down here. And this part of the box is going to represent the t, because t has been subtracted away, and what we have left over equals 3. The 3 goes here. So this model shows 10 here is what we started out with. T is taken away from 10, and that leaves us with 3. And notice how this portion of the box is dotted, just like our other box would be that used to be on this side when we were just doing expressions. And it's the same way we can break this part off as if we were giving it away or taking it away. Let's look at some more models. Addition models. We have g plus 12 equals 20. These models are very similar to the ones we've been working with. G plus 12, so we put our g and then 12. And remember, however, when we do the equals 20 part, that's our total. So it's going to go down here. Okay? Over here, 7 plus n equals 10. Remember, we're going to put our 7 in the first box, n in the second box, and our total is 10 equals 10. Okay? Now we're going to look at subtraction models. And in our subtraction models, we are going to take what we have been using and then expand on that, just like we did with the addition models. In our subtraction model, we have z minus 15 equals 30. Well, we have to start out with z, because that's the total, what we start out with. And then 15 is what's being taken away from z. So we have to represent the 15 that's been taken away from the z, and that leaves us with or equals 30. And over here we have 22 minus d equals 7. Okay, so we start out with 22, and our variable d, this represents the unknown, is being taken away from the 22, and that equals 7. So you're going to be working on this assignment. You have your math pages with you. Make sure that you are checking back through the video if you need to check your work. You're only going to do the odd numbers. I repeat, you're going to do the odd numbers only. Remember to do your whisk, and remember to leave me a note on that motto that says, Ms. Clemens, I have watched the video. See you tomorrow in class.